All right, so here's the things, and it's, again, just based on transformation rules. So the parent graph is y equals x squared. So remember, that looks like this, just a parabola that opens up. And then we just use the transformation rules from this. Okay, so from these, we know that the vertex is located at the point hk. Okay, it's the value of x that would give you a 0 here, and then the y is the vertical shift from the vertex, okay, which then gives us the axis of symmetry. Axis of symmetry is always a vertical line, so it's x equals, and then whatever the h value is, whatever your x coordinate for the vertex is. And then as far as the tendencies go, the graph opens up if a is greater than 0, opens down if a is less than 0. There's a vertical stretch if the absolute value of a is greater than 1, and a vertical shrink if the absolute value of a is less than 1. All right. Now, here is the one thing to note. The y-intercept is the value of y when you plug in 0 for x. Okay, and the reason I note this is the common mistake in vertex form is to say that the y-intercept is the point 0k, but that's not the case, right? K is not our y-intercept necessarily. Okay? So in order to find the y-intercept, if you're given vertex form, what you need to do is just plug in a 0 for x, find the resulting y value, and that's going to be your y-intercept. Okay, so the advantages to vertex form. It's very easy to graph. And you can very easily find the vertex, okay, which again gives you what are called extreme points, the maximums or the minimums. And so vertex form, if you had to choose a form, is very useful if you need a quick sketch for the graph or if you need to find the vertex. It's not very good at finding y-intercept, and it's not very good at finding the x-intercepts either. Okay. All right, so let's take an example of solving a problem or graphing one of these. All right, so if we needed to graph this, okay, as far as the pieces of information that I'm going to ask you as well. Okay, so first thing is the vertex. Where's the location of the vertex based on this equation? Remember, the vertex is located at the value of x that would give you a 0 inside the parentheses, so that would be -1, and then the y-coordinate is the vertical shift, 2. So you know that -1, 2, this is our vertex. So now, really quickly, is our graph going to open up or down? The a value is positive, so it's going to open up, right? Since a is positive. And so what this allows us to do is it allows us to label our vertex right below because we know it's opening up. So we're not going to cross through this label. And we can also find our axis of symmetry. It's x equals what? Remember, axis of symmetry is always going to be a vertical line through the x-coordinate of our vertex, so x equals -1. Okay. And then if I ask you to find the y-intercept and the x-intercepts, so these would be kind of the last two specific pieces. Okay, is this graph, let's kind of go to another tendency. Is this going to be a shrink or stretch? It's going to be, now remember, the absolute value of this number is less than 1, so it's going to be shrink. Okay, and the shrink just means it's a flatter graph. Okay, and you might also see the terminology widens. The graph widens on this. And so what this is going to look like is it's going to be like a kind of a flatter U-shaped graph. It's not going to be, it'll be a little bit flatter as it comes out. It's not going to be straight up and down. Okay, and so really from looking at this, what we should anticipate is our y-intercept should be relatively close to 2 based on the sketch and just the tendencies of this graph. Okay, and so when we look at this, let's find our y-intercept. The y-intercept can be found by taking our function and plugging in a 0 for it. So if we get 1/2 times 0 plus 1 squared plus 2. So what is 0 plus 1 squared going to be? 1. 1 squared is 1. 1 times 1/2 is 0.5 plus 2. So 2.5. So is that consistent with what we were expecting here? 0 and then 5/2 would be our y-intercept. Listen. All right, now the x-intercepts. On this particular one, the x-intercepts are easy to solve, right? What are the x-intercepts here? None, because you see it opens up and it's already above the x-axis, so it'll never come back down and pass through the x-axis. Okay, but there's a nice easy way to test this if you want to use your calculator, and that is set your function equal to 0 and solve. Okay, so if we wanted to test this, and again, we don't really need to on this one, but if we take solve, plug in our equation, so 0.5 times the quantity x plus 1, square it, and then add 2, solve for, set that equal to 0, and then solve for x. It's going to give us our x-intercepts, and it says false. It confirms that there are no x-intercepts, which again, from our graph, we expect to see. Right, so again, the other advantage to this, if you look at the advantages, are you can do this one by hand as well, right? Because we did all of this by hand. We didn't use our calculator until we solved or confirmed our x-intercepts. And now, let's say we solve this by using the same methods that we did with the TI-89. And so if we go to our y editor, and we type in our equation just as it appears. So 1/2 times the quantity x plus 1 squared, all plus 2. And we enter that. Make sure it confirms it looks exactly like what you intend it to look like. And then if we graph this, I'm going to change my viewing window back to the default settings. So -10 and 10, -10 and 10. And when I view my graph, I can find all of this information on my TI-89 too, right? I can go to my math key, hit minimum, because that vertex is a minimum value. Oops, so if I choose minimum, a lower bound, click somewhere to the left of that vertex. My upper bound, click somewhere to the right. Again, I can just pick a value for that as well. But this confirms that my vertex is -1, 2. I can see that it opens up. My axis of symmetry is a vertical line through this x-axis, or this x-coordinate, so x equals -1. My y-intercept, so I can also find my intercept. My intercept is my value when x is 0, so just type in a 0 here, and it confirms 2.5. My x-intercepts, I can see they don't exist, but I could also go back to my home screen, and in the solve feature, I can use y1 of x, set it equal to 0, solve for x. And that would be a nice, easy way to test every single one that you enter there. Again, I get a false. And so all of the answers that I just found by hand, I can also find using TI-89. And so that's what we talked about the last class. All right. So that's vertex form. Anybody know why it's called vertex form? What was the easiest thing that we could find right here? Right, the vertex is just the value of x that would give you a 0 here, and then this is your y. So that's why it's called vertex form. It's a nice, easy way to find the vertex.